Welcome to the Junk Beam. My name is Timothy Lattice, and this is the Neokino Graphics channel. This is continuing a deep dive into the AnyBeam. I have the model before the one pictured here. Let's dive into AnyBeam's capabilities according to their website. First claim, 720p. That does work at 60 Hz, just as they said. Next one, 640 by 480. I couldn't get this working. I didn't play with the mode lines that much, but the basic mode line doesn't work. Next one, 720 by 480. This one works at 60 Hz. However, I was not able to change the frequency. I just tried one, bumping up to 75 Hz. So perhaps the device is actually locked into 60 Hz modes. Next one, 720 by 576. I couldn't get this one working. Also just tried one mode line. So looking at the output at 720 by 480, I noticed something interesting. This time it's on a flat wall, and this wall is a mix of joint compound and plaster. So it's a perfect diffuse white surface. And I'm looking at the 240p monoscope, and I'm seeing some signs of resampling. So 480 is definitely not the native line count. But what is the native line count? Before I got there, I noticed some signs of digital image warping. If you look at the browser line, the gray line that's underneath the update 1 over there, it looks green due to the chromatic aberration. And notice that line is actually misaligned with the AnyBeam scanning pattern. You notice the green line actually fades out, and while another line fades in. This is the point where I started to understand what was going on. So I went back to the internet and started searching. Well, back in 2012, Carl Guttag wrote an interesting article. This article wasn't on this product, but it was on the show WX. This is a microvision-based device. You know the way the scanning of this device works. It's basically in bidirectional interlaced scanning. Notice some interesting things about this pattern. One, there's no scan lines. And two, you'll notice that there's only blanking over at the tips on the edges. But you won't get any vertical blank because it just reverses directions to fill out the other half of the screen. This is optimized for brightness, and it's optimized so that it's not going to flicker. So MEM scanning. Likely the AnyBeam uses the same show WX or microvision sinusoidal scan. As I was mentioning before, this is optimized for brightness, there's minimal blanking, and it compromises the quality at the pixels. Also, the minimal blanking removes the visible flicker at 60 Hz. The thing does not flicker, so the image is digitally warped for the screen. And I'd say this is a deal breaker. The device doesn't really have any native resolution. Everything is resampled, and everything is forced into really bad quality pulse width modulation. Has a lot of banding because it's running in linear with like 8 bits of precision. There's a second deal breaker too, and this one's perhaps just as bad, and that is that you get a variable temporal persistence. Down to the bottom where it's reversing direction, now you're going to have something that looks similar to just one frame. So you get like almost a double strobe at the top, and then in the center you have a double strobe that starts moving together, and then at the bottom it looks like just not a good pattern. So I'm no longer excited for the AnyBeam device. Even if I could get non-resampled scan and target directly, say with a compute shader doing its own filtering or rendering to the sinusoidal scan, the variable temporal persistence, there is no solution for that. Now I really want a good laser scanning projector, but this interlaced sinusoidal scan is definitely not the answer.